So part E, we've been asked that we have an additional test piece equipment attached to the instrumentation amplifier, and it requires a signal of 1 volt RMS plus or minus 0.25 of a dB for an input signal of 5 millivolts RMS at E1. It asks you what gain is required in the instrumentation amplifier. And you should assume that the power supply for the system is plus or minus 5 volts. It also tells you can ignore the effect of the series inductance within the cartridge. And that one's quite simple. We'll actually include this one here. And it then goes on in part F to say, design an instrumentation amplifier showing all resistor values and tolerances. So let's look at both of those challenges. So part E. Required V out equals 1 volt RMS. Or if you want 1000 millivolts RMS, V in equals 5 millivolts RMS, and you're given that in the question. Therefore, voltage gain equals 1000 over 5 millivolts, which equals times 200. And that was an incredibly easy 5 marks. But it does give you a little bit more information. The accuracy required equals plus or minus 0.25 dB, which, if you work that out, means plus or minus 2.9%. So if you work out what a change of 0.25 of a dB is, it's approximately plus or minus 2.9%. And a simple way of remembering this is for very low values of, say, less than 1 dB, if you take the dB figure and multiply it by 10, it's approximately that in percentage terms. So 0.25 dB multiplied by 10 would give you about plus or minus 2.5%. So that's a quick rule of thumb for converting the logs without having to go through the maths. Now, gain, differential gain, is set by RA and RB. And also R upon R for the differential stage. So showing the tolerance of 2.9%, therefore need approximately 1.5% for RA plus 2RA plus RB over RB, and 1.5% for R over R for the different stage. So resistor tolerances must be less than or equal to approximately 0.75%. Because if we take the difference stage, this one could be plus and this one could be minus. So we need to take the worst case. So if we've got a 1.5% in total, which is approximately half of 2.9%, then we can only permit R to go up or down by approximately 0.75%. And same for this one over here. We've got RA and RB. So if we calculate out the tolerance here, we can afford probably plus or minus 1.5% here, because we have 2 times RA on the top line. We've got an RB on the bottom line, which is much smaller, remember. So let's ignore RB effect there. So we have 2 resistors here. We've got a lower resistor here. So if we divide 1.5% by the 3 resistors, so resistor tolerances must be less than or equal to 0.75% for different amount. And plus or minus 0.5% for common mode for input stage, RA and RB.